Evening, everyone. Today we will talk about quite huge topic, I would say. It's infrastructure. Well, on the infrastructure in the AWS, you can actually think about almost everything that you can deploy in the AWS. But today we will talk about, let's say, basic infrastructure, which we can easily deploy in the AWS and then leverage for any of our tasks. Which one you can come up? As usual, let's wait for a couple of minutes for everyone to join. And while we are waiting, I will try to find all of the necessary links which I want to share with you today. Okay, and rearrange my windows a bit. Okay, looks good so far. Please let me know if you can see the presentation which I'm sharing and if you can hear me well. Because if there are some issues, maybe it's a good time to fix it. Okay, everything is set up. I think we are good to start. Okay, cool. So first of all, let's have a look at our today's agenda. So first of all, we'll talk about the AWS site structure. We already touched this topic at the first introduction lecture, but it's never enough to talk about it. Next, we will have a look at the networks in the AWS. How do they structured? How does they work? How are they work? And what can they achieve with a bit deeper understanding on these networks, and what can they do, and how can they do it? Next, we will talk about the security in the AWS networks. What are the mechanisms to achieve as secure as possible environment? Next, we will talk about network. Just forgot how to. What is the abbreviation? Is it so? Okay, we'll come to it a bit later. Next, we will talk about NAT gateways, the difference of NAT gateways in comparison with the Internet gateway, and it's the different infrastructures. It's the different services from the scope of AWS. And in the end, we will have a look at the task schema of the second task schema. We will try to understand what should be achieved to pass this task, pass task number 2. And for sure, in the end, you will have a chance to ask all the questions which powers you. Okay, so first of all, once again about the AWS site structure. So we have a region. So in your case, there were so many regions in the AWS. Fortunately, I can come up with exact number, but each region have its own. Some services in the AWS are region specific. So, for example, you can create some kind of, for example, EC2 instance, and this EC2 instance will be accessible for you only from this particular region. So, if you will change the region, you'll find yourself where you just can find this EC2 instance in your dashboard, just because EC2 instance, for example, is region specific resource. And all of these regions are divided by availability zones. So the minimum amount of availability zones to make a region in the AWS, I believe it's 2 or 3. So and in these availability zones is a bunch of data centers with different internet, electricity inputs, and we're absolutely independent from each other. Just in case something will happen with one data center, the second will still be up and running. And if the data is replicated if data is replicated for this exact availability zone, it will still be accessible no matter what happened with one of these data centers. And actually, there are some, let's say, some of the resources are deployed not in the regions, but in the availability zones. And yeah, I just mentioned about the EC2 instances, but actually EC2 instances, in EC2 instance, you can deploy especially on the availability zone, but not on the region. And there are some restrictions, and there are some things which you should keep in mind when you are working with the availability zone. So for example, if you will create the EC2 instance in the availability zone B, and you would like to create the disk block storage for this EC2 instance to attaches block to the block storage to the EC2 instance. And if you will create it in the other availability zone, you will not have an option to connect both of them to each other, just because, for example, disks and instances should be in the same availability zone to be able to connect to each other, to be able to attach volume to your EC2 instance. Okay, and the thing is that network is not that simple as it is in your, let's say, home laboratory. Yeah, let's say right now you have only one router, and this router is routing all of your requests to the outside of internet, and this is it. So I believe you have one subnet for all of your home devices, and it should be something. It should be not the public, but private subnet, something like 192.168.0.0 or something like this. So we will have a look at the networks a bit later. But now just to understand how networking works in the AWS. So first of all, you have VPCs, which stands for Virtual Private Cloud. And this is actually this is actually quite huge resource which you create for your region and to the region you're working in. And under the VPC, we can understand all the set of networks, subnets, security rules, network access lists, and everything else. So whichever resource you would like to deploy, you will deploy it in the VPC. So okay, maybe it's not as easy as it is, just because you can deploy even Lambda function or something like this, and it will be not VPC dependent. But still, you have a chance to deploy your Lambda function in the VPC. But now we are talking about EC2 instances. So first thing you need to create, but actually you already have the default one. So whenever you're creating your account, you're already provided with default VPCs in all of the regions. And this is free of charge. So you can create as many VPCs as you want, and it's just your property. You don't need to pay for it. You can play with it and run some experiments or tests absolutely free of charge. And when we are creating the VPC, so we need to, the only thing we need to specify is the subnet. And it should be the subnet which you will use for all of your deployments. So after you created the VPC, so for example, it will be 10.0.0.0/8, and it will be your VPC. And on the next steps, you will need to create subnets. Subnets is the thing in which we can create our resources. So for example, we need to create EC2 instance, so we will create it in some particular subnet. These subnets will divide in our VPC on, surprisingly, subnets. So if we already have 10.0.0.0/8 the VPC, we'll need to create the subnets, which, for example, maybe 10.1.0.0/16. And this particular subnet we can create in our resources. So let's say EC2 instance. It's a good practice to deploy your application in couple of availability zones inside of one region. So it's a good idea right now to create not only VPC, but a bunch of subnets each, and one subnet per availability zone. One more best practice thing is to create the private and public subnets. We will talk about the difference a bit later, but keep in mind that, okay, if you are creating the subnet in the availability zone, it's a good idea to create two of them. So one will be for the public resources and the second one for the private ones. And if you're talking about this, your local network, so at your home, you have the router, and this router is responsible to route your requests to the web pages, for example. So if you are going to aws.console.com, in this case, a router will know what he will need, first of all, to go to the DNS server somewhere in the internet and ask him, okay, so what is the IP address for this particular web page? And it will ask it, and the response will be landed on your router. And your router will know what, okay, looks like it's a response just because I can see all of the necessary headers. And this response should be to someone who asked about where aws.console.com is. So it will land it on your local PC. This is how it works. So this is how, okay, let me just Google what NET stands for. It's just absolutely okay. It's network address translation. Yeah, exactly. So this is the idea behind the net. So you don't have the public IP address on your local machine, and even in your smartphone or just whatever. So every time you're going outside, you are covered by the IP address of your router or router of your ISP. Okay, so few words about the subnets. So first of all, we have the public and private subnets. Public subnets is the ones which are publicly available. So it's actually all of IP addresses in the world except three private networks. First one is 192.168.0.0/16. So there are no public IP addresses under this subnet. You can use it in your local networks, and this networking, this subnet, will be only accessible inside of this particular network. So it can't be reached from the outside, except you'll set up some port forwarding or something like this. And there are two more of them. The second one is 172, and I can come up the second and third octets. And the third one is 10.0.0.0/8. And if we will have a look at the IP address structure, it's 4 octets, and usually it ends up with the subnet mask. Sometimes it's specified by just putting some digits by the slash. So it's 192.168.100.10/24, for example. And this 24 will stand for the mask. And this mask is the thing that separates the subnet from the bigger ones. So as I already mentioned, so if you have in the VPC, it's 10.0.0.0. So it's a good idea to create a subnet, and this subnet will divide your, let's say, global subnet on these smaller pieces, just to isolate the instances, or maybe not only the instance, but any compute power, any resources, just to separate them from other networks or other resources. And yeah, actually, there is also a table on how many hosts can be inside each of subnets. So if you are talking about /8, which stands for 255.0.0.0. So in this case, we will have, whoa, so much. It's almost 70 million hosts. But if you're talking about something a bit smaller, so /29, for example, we will have only 6 hosts. This is how you should adjust subnets in your networks, in your networking environment. So if we will talk, okay, yeah, let's talk about it in the end when we will have a schema in front of us. Okay, so, and just to secure in our network, we have two entities in the AWS. So first one is security groups. Security groups is the thing which we can attach to in our EC2 instances. So for example, we would like to restrict all of the connections to in our EC2 instances, except, for example, port number 22, yep, just to have an SSH access to it. And this is a place where security groups comes to the table. So we can just create a security group which will restrict all of the traffic, but it will only access the traffic to in our 22nd port of an our EC2 instance. Next, we will apply the security group to our EC2 instance, and this EC2 instance will become just available via the SSH protocol. So we will have an option to connect to it. And maybe the better example, a better example is when we would like to make our application accessible from the internet. So we can create a security group which will have port number 8080 opened and attach it to the EC2 instance. And moreover, we also have an option not only open ports, but we can open the ports for some specific subnets or even for other security groups. So for example, we have a Bastion host and we would like to have an option. We would like to allow all of the SSH connections only from this particular Bastion host. And we know what this Bastion host has itself security group. In this case, for in our EC2 instances, we'll need to create the security group, which will allow all of SSH traffic from the security group, which is applied to the Bastion host. This is how it works. And on the other hand, we also have network access control list, NACL. And this is actually, I think, the additional layer of a security. It's not a mandatory one, but still, you still need to know about it. So network access control list gives us an option to apply some security groups, some security rules. So in our subnets, if you're talking about security groups, it's applied to the resources. But if you're talking about network access control list, it's applied to the subnets. So, and in these subnets, we can specify actually pretty the same. So we can just say that, okay, so we have the SSH to this in this particular subnet. Only these IP addresses have an option to connect via the SSH. But yeah, an ACL is a bit more, let's say, advanced topic. But if we will talk about the security a bit more, so yeah, it's, I would say, mandatory one. I believe in this task, we will talk only about security groups, but we will have a look at it a bit later in the end when we will try to understand what is required in this task. Okay, let's move on. So network. Oh my God. I don't know what's wrong with me today. Network address translation. So this is how it works. Okay, I just had a look at the chat. Okay. So I already mentioned how it works. So whenever you're making any requests to outside of the internet, the net gateway is responsible to translate your internal IP address to the public one to make it possible to connect to any outside of your network resources, or in other words, to the public resources, and to make these public resources be able to translate, to give a response back to you. But actually not to you. This public resource will only know about the net gateway IP address, but net gateway will be responsible to translate this response back from its own public IP address to your private one, just to give the response from the public internet. Yeah, exactly. Thank you. So I'll keep it posted here in the chat, so I'll have a look at it. Okay, and in your home network, as I already mentioned, I believe you only have the router, which is responsible for all of the operations from your laptop, for example, from your phone or just whichever network device, um, to make it possible to make this device be able to talk to outside of the internet. But if you're talking about the AWS, we're another entity available. So it's Internet Gateway. Internet Gateway actually gives us an option to mm, uh, gives an option for in our resources to talk to the internet. Without it, it will be impossible. So we still can create an EC2 instance, and this EC2 instance will be available for us for via the SSH, for example. We still can connect to it. But if you would like to run, I don't know, maybe some security updates, and we would like to update from the public repositories, it will be not possible if we will not set the internet gateway up. Just because this instance will don't have an access to the outside of our subnet. It will be only deployed in our VPC without any access to the internet. And even if it has the public IP address, yeah, it's still not possible. And there are actually two options. So first thing is we can deploy Net Gateway, and we can route all of the traffic from our EC2 instance to this Net Gateway to make this address translation and land in our request to necessary resources. But we still can have an EC2 instance without public IP address. And in this case, that gateway is mandatory for us. So it doesn't matter if we have an EC2 instance without the public IP address, and for example, we have on the internet gateway, this EC2 instance will still don't have an option to go to the internet just because it doesn't have the public IP address. But this is the place where NAT gateway can help us. In the production environment, it's quite usual situation where you have something deployed behind the firewall, and in this case, it's NAT gateway. And this instance is just not accessible from the public internet. So you just can't connect to them. They don't have the public IP address. You can connect to them directly via the SSH port. And on this instances, your application may be running, or maybe database can be running on this instance, or maybe actually just both. So you have two instances, one for your application, one for the database. They can connect to each other, but they can't be accessible from the outside. And as a best practice, we'll have a look at it a bit later at the next slide, I believe, or yeah, at the next slide. So we will have a look at the structure, which is desired for the test number 2, and we will try to understand which instance hides behind the internet gateway and which can hide only behind the net gateway, and which of them will be known as public and which of them as private ones. Okay, let's have a look at the schema. So, okay, I'll make screen a bit bigger from my end. Right now we have two schemas. Actually, they serve the same purpose. The difference is the left one has NAT gateway. The problem with NAT gateway is what it's not included in the free tier. So whenever you're creating the NAT gateway, you will be charged for the time it's deployed. So this is why we just created the second schema, which also serves the same purposes. So it just gives an option for the public and private instances to access to the internet. But the thing is, but on the right side of the screen, you are creating or deploying the NAT gateway on your EC2 instance. So, and your EC2 instance is running all of the necessary software to make it act as a NAT gateway. So just to translate all of your requests to the public internet and back. So, but let's focus on the left one. Actually, they're not different that much, but at least at the left one, we have the NAT gateway specified right on the screen. So, first of all, you can see that all of the resources deployed on one AWS account. So this is the first square. The second one stands for VPC, the purple one. And this is a VPC. It may be the default one, or you can come up and create your personal one via Terraform. It's not that hard. This VPC is divided on the subnets. And as you can see, there are 4 of them. 2 subnets per availability zone. Some of these subnets called public, and some of them are called private subnets. And as you can see by following all of these arrows, so the private the subnets just doesn't have any connection to the internet, just because it's not necessary for them. They only can go to the internet via the NAT gateway, and it's just enough for run, let's say, security patches, some updates, or just whatever. But they are not available from the outside of the internet. But if you are talking about the public subnets, these EC2 instances in these subnets will have public IP addresses, and they will be accessible from the outside of the internet. And if we will have a look at the upper one, which is a bit more bright, so I believe this instance is specified a bit more brighter, just because it has all of the necessary security policies just to make it accessible via the SSH from the outside of the world. But the second one is not. So this is how it works on the production. Usually we are just exposing only one instance to the outside of the world, and opening some particular port. So it may be 22, or just whichever port you would like to use for the SSH connections. For sure, use port number 22 is not secure, just because it's the default one. So usually it's better to change it. And this Bastion host, also known as a jump host, serves all of the connections, but there is nothing on this Bastion host actually deployed. So it's only serves as okay, exactly, as a Bastion. So we're just connecting to this one, and once we are connected, we have all of the access to in our EC2 instances in all of the public and private subnets. So from this Bastion host, we can connect to all of Arthur and our EC2 instances. This is how it usually works. It's actually made just to secure all of the connections. So, for example, if someone will have a so the thing is, you will need to secure all of the connections only on one host. Yeah, and this is how it's just you just making it a bit less complicated. So you can just attach all of the necessary security groups to one instance, make it barely available, and then all the rest of the connections will be will not need to be as secure as the connections to the Bastion host. And this is actually a desired schema for the second task. So what do we really need to do in this task number 2? We need to deploy all of this infrastructure using the Terraform code. How to do so? I believe the next slide is the last one. So let me share my screen. Okay, maybe, yeah, first of all, I'd like to share this link with you. So by following this link, I'm not sure if I can paste it in here, but you can follow the Amazon Q workshop, which we provided a couple of months ago. And this is, on this workshop, we just shown the AWS representatives how to install Amazon Q. Amazon Q is artificial intelligence. I don't know. I can't say what it's chat. So it's a tool. It's AI tool which gives you an option and which helps you to deploy all of the resources. And using this as an LLM model, you can get information about all of the resources in the AWS, how to deploy them, and so on. So it may be very helpful even if you are talking about the Terraform. So you can always ask him, okay, so how to deploy, for example, VPC with a bunch of subnets, public and private ones, internet gateway, NAT gateway, so on, and create a couple of security groups, and it will just help you to deploy it. But the thing is, please, even if it will work from the first time, spend some time just to understand what actually just happened when you got all of the production ready code. So just try to read through it, try to understand how it works, and what exactly just happened in this code. What happens in this code. So now let me share my screen. So let's walk through the task itself. Okay, how can I? Oh, bear with me for a second. So I'll share my screen. So yeah, let it be entire screen. Screen number one. Uh, okay, yeah, exactly. So let me rearrange it a bit. Okay. Okay. So hope you can see it well. Uh, okay, the task starts from the same schema which we've been looking at right now. So it's the same for EC2 instances located in different subnets in different availability zones under one region. With internet gateway and okay, the net gateway is missing, but yeah, still. Okay, what is required? So first of all, we need to create VPC to public to private subnets, internet gateway, and some routing configuration. So instances in all subnets can reach each hour. How to verify if it's done? Uh, I think we have some notifications in the validation criteria, but I'm not sure. Instances can reach each hour. What should we submit? Define variables, verify configuration, submission creator, create pull request, provide screenshots of resource map screen. Okay, yeah, exactly. So this thing actually can give us a clue on what happens in our VPC. So just to find this one, we can go to the VPC, your VPC name, resource map. So let's go ahead and let's verify if it's possible from my end. So it's VPC. And where is your VPC? And this is my, not sure if it's default one, but it's some nameless. And on this resource map, you can see that I have 4 different subnets, and all of them are pointing to the routing table, which point into the internet gateway. So in this case, we can understand that all of my subnets are public because all of them are pointing to the internet gateway, and I believe all of the instances will have the public IP address. Okay, so once we are done deploying the VPC, deploying availability zones, internet gateway, we still need to deploy some routing configuration, and instances in public subnets can reach addresses outside VPC and vice versa. So I believe it means what we can try to ping something outside of an hour VPC. So it may be Google DNS, which is usually used just to verify if everything works fine from the network perspective. So you can just try to ping 8.8.8.8 just to verify if the public internet is accessible from your end. You also need to organize your code. As I already said on the first session, so you can define all of the resources in one .tf file in the Terraform, and Terraform will verify that, okay, this is all of the resources, and I will just deploy them. But it's a best practice, and it's a good idea just to separate them. So you can create the VPC or maybe all of the network-related stuff in one file, and then EC2 instances in another file. One more file you can create just to specify all of the variables which will be used during the deployment. Because in the production environment, you will have not only production environment, but also something for development, something for QA, and for all of these different environments, all of the variables for these different environments may be managed by Terraform. So you can specify that, okay, if dash, for example, if dash production flag provided to the Terraform plan and Terraform apply. So, okay, I will need to use the production variables. This is how it works. Separate resources into different files for better organization, and define variables in separate variables file. Okay, verify configuration. Next, you will need to run Terraform plan just to make sure that, okay, everything is about to be deployed. And in the end, when all of it deployed, so you are good to submit your task. As an additional tasks, implement security groups. Okay, it's not mandatory here, but yeah, I think I'm not sure if you will have an option to connect to have access to your EC2 instances. Okay, to make sure that your EC2 instance is accessible from inside of your subnet without any security groups. So yeah, even if it's additional tasks, so you will need to come up and do them, create them, just to make this one. I'm not sure, but yeah, if I'm wrong, just let me know in Discord, please. Create a bastion host for secure access to the private subnets. This is what I just explained to you. So it's a best practice to have only one instance being accessible via the SSH from the internet. This is called bastion or jump host. Organize net for private subnets. Okay, it's an additional task, but keep in mind that Net Gateway is not in the free tier. It's not covered by the free tier, so you will be charged for it. But only if you will come up with the idea how to create the NAT instance. So, in other words, an instance which will serve the purpose of NAT Gateway. And document the infrastructure setup and usage in README file. It's just as a best practice, so document whatever you do. About the submission, I already saw the question in the Discord channel about okay, what we're gonna do if our task is still not checked, but we already need to create a task number 2 branch. There is nothing special about it, so you can still merge your pull request in your main branch, and your pull request link will still be available with all of the conversations, with all of the changes in the file, and so on. And then you can create the task number 2 branch from the main one, and then do all the stuff in here. Provide screenshots of a resource map screenshot. Oh, come on. Okay, I'll fix the wording here. In the pull request description. So you will need just to create a screenshot of this one, and what should be visible on it. So in my case, it's just for public networks, but in your case, it should be something. It should be something a bit different. So 2 of them will not point to the network connection. They will only point. They will be okay. They will just disconnect it from the root table. Oh no, they will be connected to the root table, but they will don't have access to the internet gateway. This is how it should look like. And in the end, provide screenshot, optional, set up GitHub Actions pipeline for the Terraform code. It will be, I think, a bit more convenient for you and just for educational purposes. So you can set up the GitHub Actions pipeline just to make sure if it's working, and you can run all of the init, plan, format, and apply commands from the GitHub Actions. About the evaluation criteria. So if you just succeed with deploying all of the infrastructure via the Terraform, you will get 50 points. Code organization. If it's not just placed in one file, but separated on different files, plus 10 points. Verification. If screenshot is provided and Terraform plan is executed successfully, plus 10 points, and 30 more points for security groups, bastion host, net implementation, documentation, and submission. Okay, yeah, one more thing to be fixed. And a couple of documentation sources just for you to make it a bit more easier to understand how to deploy, how to create all of these resources. Okay, at this point, do you have any questions? Let me have a look at the chat. Okay, the first one. Will network latency increase when we create 2 network connected apps into different AZs instead of deploying these 2 apps in one AZ? Uh, I'd say no, just because all of the data centers are connected via the fiber network. And as we know, the fiber network operates at the speed of light. So, yeah, mm, it will be, you'll not feel it actually at all. And if you are talking about the applications located in different availability zones. So usually between, okay, not between, but before these instances, load balancer will be located. And this web load balancer will serve all of the requests to your application, and it will land this request to your instances. So, but yeah, there will be no any fillable latency if you are talking about the different availability zones. Mm. Do we need to keep all of our AWS info running 24/7? Or can we set up EC2 instance to save some costs? Uh, it's actually a good idea to start and stop instances. And actually, we made this course, keep it in mind, but some of these resources may become, you may be charged for a couple of them if we're deployed 24/7. So yeah, you need to create them. You need to verify that everything is deployed and everything is accessible as it should. Create as many screenshots as possible and attach them to the pull request. And then you can just stop these instances or even destroy them using the Terraform. Just because no one will have an access to your AWS account and no one will have an option to verify if they are really deployed or not. So choose to deploy it, and then if you need it, if you don't need it, just destroy it, and it will be as easy to redeploy all of it as by running Terraform apply. And this is actually, do we need to create all EC2 instances in task 2 or just the Bastion host in public subnet? We need to deploy all of these instances, actually. It's just for you. Okay, maybe we will not have an option to verify just because we are not specified, but you need to attach the screenshot of your EC2 instances deployed. And our fault, yeah. But just for educational purposes and just for you, it will be a good idea to deploy 4 instances and just verify that, okay, right now you can connect to the Bastion host via the SSH, but you can't do so to the rest of instances. But once you connected to the Bastion host, you have an option to connect to the rest of instances. And it will be a good task for you. And this is how most of the production networks work. So when you will go to your first interview, so you will be already knowledge about what Bastion is, how it works, how to leverage all of its advantages. Does everything need to be done via Terraform or can also be done manually? I believe Terraform code should be submitted. But believe me, deploying it via the Terraform will be much easier for you than deploying it manually. Just because you can go to the ChatGPT, for example, or any other LLM and ask him, okay, please deploy for me VPC, 2 public subnets, 2 private subnets in different availability zones, and so on. And it will give you the Terraform code, which will almost for sure it will work. Just because we're nothing complicated in the Terraform, and it's just the description of a desired state of our infrastructure. You can go and after ChatGPT or whatever will give it to you, just go to the official Terraform documentation and try to understand what actually just happened, and does all of the options were specified by needs, or maybe there may be something extra which you can from which you can get rid of, and then just try to redeploy it and so on. So just try to understand how Terraform works. It's really quite easy and convenient tool for deployment. Why we can go back to main branch without measure? Actually, you can. Maybe it's not a good idea just because the changes from the task number 1 will be not included in your new branch. But why not? Yeah, actually, you can create a branch from the task number one branch. Uh, it's still a good point. Yeah, just use the method which is more convenient for you. To the main branch without mentioning and create task two from clear main. Yeah, maybe just because the changes will be from the task number one also, if you will not merge task one to the main. Uh, Format will mess up the block you're using inline commands. Um, didn't get it. Okay. If you could try to elaborate on it a bit, so yeah, it will be good. Should each Terraform task be in the same folder or in separate folders like this? It's a good idea to place all of the Terraform code in one folder, just because in our way you will need to say to the Terraform in which folders it will need to seek for files. So yeah, it's a good idea to place all of the files in just one folder. And should each lab build on the previous one or start fresh every time? You can build on your existing environment. So you will have, right now you have the Terraform state placed somewhere in the S3 bucket, and this is probably it. But in this task, you will need to create the VPC, subnet, security groups, EC2 instances, so on. So yeah, just deploy them in the existing environment. You can actually Terraform destroy. Yeah, exactly. Okay, and yeah, actually, just to verify if something just doesn't work on your environment, and you'd like to verify why why does it not work. So you always can connect to your instances via the AWS console. Once you'll create an EC2 instance, you will have, okay, I'm not sure if I have any. Yeah, unfortunately. But you will have an option to choose this EC2 instance and choose and click on the connect button. It will give you an option to connect this EC2 instance inside of this EC2 instance and try to understand what actually wrong with it. Okay, yeah, exactly. Therefore, oh yeah, makes sense. Makes sense. But actually, you can create your init script in the separate file and call it something like .tpl or something like this. And during your and inside of your Terraform code, you can specify the block which will take this file and render it. And then inside of your EC2 instance, you can place just the render of this file. I'm not sure if Terraform format will go to the files which are not .tf named in the end. So yeah, maybe the information I gave you today is a bit too much, and maybe I missed something. But you can always ask any questions in here or in the Discord channel. We will try to help you. If you are missing any understandings, it's a better idea to run some linter with git pre-commit instead of separate Terraform format. Yeah, is there something special about the Terraform format? I'm not sure if we have it in this task, so you could just skip it. Actually, it's a best practice to run it, but it's not necessary to do so if you have any conflicts. But what do you Ansible? I'd say Ansible is serves a bit different purposes. Right now, we are not talking about the software installed on your virtual machine. For sure, you can deploy. For sure, by leveraging AI Ansible, you can create instances, but it's not that convenient as Terraform. Okay. Any more questions? If not, so let's call it a day. And if you will have any more questions, feel free to ask them in the Discord channel. If you have any organizational problems or some concerns, feel free to reach me directly. So I will not miss your message for sure. Thank you so much for being here today. And I think see you in a week where we will finally talk about the Kubernetes, I believe. Yeah, exactly. Kubernetes. Okay. Thank you so much. See you in a week. Cheers. Bye.